This is Mr. Elmhorst with the Mastery Practice help video for solving one-step equations. So we're going to use inverse operations to solve and write an inverse equation. It's pretty straightforward. I want to see the strategy that we learned in the lesson. Find your variable term and separate the left side and the right side. So put a line down through the equal sign, use a stylus, use your finger. So this work is a simple process, but when we get into multi-step 3, 4, 5, and 6-step equations, this process is going to become more important. So identifying what is happening with the variable, something goes in -6 and that equals 12. The mental math on this, is 12 minus 6 equals 6. But how do we go through the process of solving? We're going to start on the side where the variable is, and then start with inverses. So bring the variable down to the next step, and then the solve. So what would be the inverse equation? V is equal to 6 plus 6. That's how we ended up solving it. Okay, looking at number 2, we're going to identify the variable term is now on the right side. And what is happening to the letter F? It's being divided in fraction form. So the inverse or the opposite of dividing is multiplying. Okay, so we're going to separate the left side and right side, and then whatever we do on the side with the variable, we're going to do the equal thing on the other side of the equal sign. So divide by 3 and times 3 is going to cancel. Now we have the variable f by itself, 1f, and then 3 times 9 is 27. So the inverse equation that we used to solve was f is equal to 9 times 3. We did the opposite of dividing by 3. So number 3, we have the variable term is on the left side of this equation. Draw a line down through the equal sign. And the fraction line means division. So in order to solve, we're going to multiply. So there's different forms of multiplication. Here, take a look at this. You could represent it as parentheses 2, or you could put times 2 or dot 2. Whichever form of multiplication will be correct. So times 2 divided by 2, now we have, after one step solving, z, the unknown, z is equal to 6 times 2, which is 12, and a negative times a number is going to stay negative. So what did we do to solve? Z was equal to -6 times 2. Okay, looking at number 4. Find your variable, circle your variable term, your letter, and the sign to the left. Not this. It's not just n. Every year I have to have students focus on circle the letter and whatever sign is to the left. All right. Now, we put a line down through the equal sign just to help us understand that when we're working on the variable side, that we're also doing the same thing on the other side. So this is a positive n. And n plus 2, or 2 plus n, whatever is being added to n, is this a positive or negative 2? Okay, so we're going to inverse what is over here with the variable. The opposite of 2 positives is 2 negatives. Now this is going to cancel. Now we're left with n as the variable, and n is equal to whatever we did on the other side. So what is 8 minus 2? 6. All right, so what did we do to solve? We had n is equal to 8 minus 2. So let's go back up. You don't have to erase this. I'm just going to clear this off so we can see. N minus 2, or 8 minus 2 is 6. So if we put this in here, we were looking for something, a number plus 2 that equals 8 as the output. So here's our input, and then we get our output of 8. What number do we need to put in for our input that makes it true? What number is it? 6. So 6 makes it true. So number 5, what is our input variable? What letter do we have for number 5? H. So we're going to circle H and the sign to the left. If there's no sign, then we're going to treat it as positive. And then something happens. Then we go across the equal sign to the output. We need to put some number in, and 5 is coming out. What number would we subtract 6 from that gives us 5? 11. So we know H is equal to 11. You can probably do mental math on that. Okay. What's the opposite of subtracting 6 from H? So we're going to add 6 to the right side and then go over to the other side and add 6 to help us solve and do inverses. So now that we've done the inverse of subtracting 6, we added 6. Now we have H is equal to 11. How did we get 11? H is equal to 5 plus 6, which is equal to 11. All right, let's take a look at number 7. What are all the math operations we could possibly use? Adding, subtracting, multiplying, or dividing. Now, with the multiplication, multiplying is also if you put a number next to another number in parentheses, or if we do, let's say, for example, 3 times the variable c, or we could do 3.6. All of these represent multiplication. Division, you could also have, let's say, 6 over 3 as a fraction. We could also have 6/3, and we could also have 6 divided by 3. So these are all forms of multiplication and division. So we go over here. If you look at 3, we have 3 of the letter C's. So what is 3 doing to the letter C? What is it doing? Okay, so 3 of the letters, you can put a little dot in there. It also means you're multiplying by 3 of them. So the opposite of multiplying by 3 would be coming down and then dividing by 3. What's one way we could represent dividing? A fraction. So you do divide by 3 on the left side, and then we go to the other side and we divide by 3. So what is 3 divided by 3? 1, and that's 1c, and that's what we want. We want a positive variable, positive 1 variable equal to something. And what is negative 33 divided by 3? 11. So C, the input to this situation that makes this true is negative 33 divided by 3, which equals negative 11, is what we need to have as our input in order to get negative 33 coming out. So number 8, what's the opposite of multiplying by 6? We're going to divide by 6 and then go over to the other side of the comparison symbol, and we're going to divide by 6 also. 6 divided by 6 becomes 1y, or just y, and 30 divided by 6 is 5. So how did we solve it? We did 30 divided by 6, and that told us that the input, the number that goes in here, is the number 5. That makes it true.